All right, so today we're going to be talking about geometric series. We talked about arithmetic series yesterday, and we know that series is when you add up a whole sequence. So a geometric series is obviously the sum of a geometric sequence. So we want to remember that a geometric sequence is when we're multiplying by the same thing every time. Sometimes it's a whole number, sometimes it's a fraction, but we are multiplying by the same thing every time. So as long as the numbers in the series are being multiplied to get to the next number every time, it is geometric. Just remember, series means that we're adding up all of the numbers, so there's a lot of plus signs, as opposed to a sequence which just lists the numbers and has a bunch of commas. Geometric series. Just like with arithmetic series, you can physically take all of the numbers in the series. If it's 10 numbers, you can take those 10 numbers and add them up. However, in lists longer than 10, that's just not terribly convenient. And so we learned for the arithmetic series that there is a formula. For the finite geometric series, there is a formula so that if you know how many terms that you want to add up, and you have the explicit formula, you have the first term, you have the common ratio, those are all the things that you need, you can find the sum of a finite geometric series. So here's our formula for the sum of a finite geometric series. Things that we want to make sure we remember what everything stands for. Don't forget, a 1 is equal to the first term. So if we don't have the explicit formula, but we do have the list of numbers in front of us, we can at least look at it and see what the first term is. R, if you have forgotten, is the common ratio. So what is it that you're multiplying by every time in the sequence? So the common ratio. And then N is still our number of terms. Are we trying to find the sum of the first 10 terms? Are we trying to find the sum of the first 100 terms? How many terms are we trying to find the sum of? So N is how many terms are we looking at? All right, so let's take a look at a couple of example problems. So here's our first example problem. We want to find the sum of this particular series. It's a series because we're adding. Now, don't forget, subtraction is technically addition. It's just adding a negative. So this is a series, and we want to find the sum of this series. Now, this series is only 5 numbers. So I could technically grab my calculator and add them all up. Negative 45 plus 135 plus, let's go back and fix that, minus 405 plus 1,215 minus 3,645. Enter. All right. So negative 2,745. So that is okay. That is not cheating. Okay? You are finding the sum of a series. There's nothing that says you can't just add those numbers up. That works. All right? If you didn't have just 5 numbers, let's say it was 15 or 20, you can use the formula. So let's review real quick just so you'll know how to use the formula. S is equal to A1 times 1 minus R to the N all over 1 minus R. So in this particular problem, we would need to know what is A1. Well, A1 is negative 45. So that gives me the first number to plug in, negative 45. And I know it's going to be 1 minus R. So what am I multiplying by each time? I might need my calculator for that. What is 135 divided by negative 45? Negative 3. So let's double check. 135 times negative 3 does in fact equal negative 45. So R must be equal to negative 3. Minus negative 3. The negative is important. You have to keep it there. N is how many terms are there. So there's 1, 2, 3, 4, 5 terms. And it's all over 1 minus R. And R was negative 3. This is the formula, folks. If you try to type this all into your calculator at one time, you're more than likely going to make a careless mistake. This is just one of those things that you want to do in phases. Okay, now you can use your calculator. For example, I need to know what negative 3 to the 5th power is. Please notice, when I type in negative 3, it is in parentheses. If I do negative 3 to the 5th power and don't put it in parentheses, I am going to get a wrong answer. So negative 243. So I've got negative 45 times 1 minus negative 243. All right. Now on the bottom, I can go ahead and do 1 minus negative 3. If you remember, minus a negative is plus a positive. So that'll be 1 plus 3, which is going to be 4. Need to do the same thing up here. 1 minus a negative will be plus a positive. So that's actually going to turn out to be negative 45 times 1 plus 243. So that'll be 244 all over 4. Now that's something I can type in my calculator all at once. Negative 45 times 244 divided by 4. And look at that. Negative 2,745. Now you'd be saying, Ms. Parker, why in the world would I do that really hard formula when there were only 5 numbers? I agree. These were 5 numbers. They gave me all 5 numbers. I would just add that in my calculator and get the sum. However, I wanted to show you how the formula worked because for longer things, you're going to have to use a formula. If we were finding the sum of the first 20 terms, they may have only given us the first 3 terms. So we didn't even have all 20 terms. It's much easier to use the formula because with 3 terms, I have the first term, I can find R. If I know I'm looking for the 20th term, I have everything for the formula. And so it's much easier when you're looking for the sum of a longer series. I agree, this one only had 5 terms. I would probably just add them up. Alright, so let's look at another example. Alright, now don't forget summation notation. Exactly the same. Identical to an arithmetic. All right, it's a series still. It means the sum of. We want to find the sum of the first to the 4th term. So that's 1, 2, 3, 4. That's 4 total terms. And then they gave us the explicit formula. All right, so things that we know, we've got to remember. Here is our R. The base of the exponential is always the R. Now you need to be careful. If this is n minus 1, then this is the first term. But if this is not n minus 1, you are going to have to plug 1 in to find the first term. Now, you've got a couple of options for this one. These are only 4 terms. You could just plug in 1, plug in 2, plug in 3, and plug in 4. Find your 4 terms. Add them up, and then you've got the sum. Or you can use your formula. So, again, I'm going to probably practice using the formula. A1 times 1 minus r to the n power all over 1 minus r. So, things that I know that the ratio, the r, is 4. So it's going to be 1 minus 4. Now, I know that I'm looking for the first 4 terms, so it's going to be to the 4th power. And I know that it's going to be over 1 minus r, which is 4. Now I need the first term. To find the first term, I've got to plug in 1. So 4 to the 1st power would be 4. 4 times 2 would be 8. So the first term is actually 8. So we end up with 8 times, now let's see, 4 to the 4th power. 4 to the 4th power is 256. So 1 minus 256 is going to be, let's see, 1 minus 256 is negative 255 all over 1 minus 4, which would be negative 3. So we get to our calculator, 8 times negative 255 divided by negative 3, is 680. And there's our sum. Excellent. Now, here is a major, and this is a very major difference between an arithmetic series and a geometric series. For arithmetic series, we could only find the sum of a finite series. It had to be finite. If it was infinite, it was going to keep getting bigger and bigger and bigger and smaller and smaller and smaller. It wasn't going to have a sum. But some geometric series that are infinite can have a sum. Now, not all infinite geometric series have a sum, just some of them. And the ones that do are if r, the common ratio, the absolute value of it is less than 1. Okay, we're talking about something like 1/2, negative 1/3. 0.25, 0.5, 0.7, okay? Anything basically between -1 and 1 is what we're looking at. Now, just because it's a fraction doesn't mean that it's less than 1. 5 halves is a fraction, but that's not less than 1, okay? So it has to be something that is less than 1. Its absolute value has to be less than 1. But if it's less than 1, that means that all the terms in that series, all the terms in that sequence are getting smaller and smaller and smaller and smaller. We're dividing. Okay? And so it's getting smaller and smaller and smaller. Eventually, it's going to get so small that we're really not adding anything. And so that's why they have a sum. If it's a number bigger than 1, then we're multiplying by something every time. That number's getting bigger and bigger and bigger and bigger every time, so we're always adding something. It's never going to have a sum. But if r is less than 1, then it does actually have a sum, and it has its own formula. And I have to be honest, the formula for the infinite series, way easier than the sum for a finite series. It is just the first term divided by 1 minus r. Minus that whole parentheses and r to a power and all of that kind of stuff. It's fabulous, much easier. Now, an example problem, a couple of notation things you need to make sure you know. This little symbol is the infinity symbol. Okay? So if you see that over a sum, a summation, all right, that means we want to find the sum from 1 to infinity. It is an infinite series. Now, if it's geometric, and if its r is less than 1, we can find that. If it's not geometric, if it's arithmetic, it's not going to have a sum. If it's geometric and the r is bigger than 1, it's not going to have a sum. All you can do is say, no sum. But in this case, we look at r. R is 1/4. 1/4 is less than 1. All right? So now we can do it. We have our formula. The formula is equal to the first term over 1 minus r. So things that I know r is equal to 1/4. So 1 minus 1/4. Now, I do need to find my first term. 1 minus 1 is 0. Anything to the 0 power is 1. And 1 times 3 is 3. Now I just got to plug everything in. 3 divided by 3/4. So 3 divided by 3 divided by. Now guys, if you're going to type a fraction into your calculator to divide by it, please make sure that you actually put the fraction in parentheses. So that's equal to 4. So the sum of this infinite geometric series would be 4.